Okay, let's get started. So today we're going to go over just some chapter 4 problems that could be on the test tomorrow. All right, so let's see. This is going to be, you have the blue book. I'm pretty sure it's the same as the other one. The page is 305 to 307. So that's where I'm getting these problems. There is the review problems in the book. So let's start with we could do 10 and 11. So for this is about end behavior. So we want to state the end behavior. Let's write like this. So for number 10, we have f of x is equal to minus 1/2 x to the 4th plus 3x squared plus x minus 6. And remember, with end behavior, all we care about is the term that has the biggest exponent. So in this situation, the term with the biggest exponent is this term. And so our power is an even, and the number in front is a negative. So if you go back to the chart, whenever we have, so here our leading power, the leading power equals 4, which is even, and then the coefficient is minus 1/2, which is negative. And so whenever you have an even and a negative, our end behavior is this. It goes down on the left and goes down on the right. So we had that, we had the whole chart that has all the different options. And so if you look at an even power with a negative coefficient, this means that the end behavior is this. So it goes down on the left and also down on the right. So for number 11, we have f of x is equal to x to the 5 plus 2x cubed minus x squared plus 5x plus 4. So here our leading term, the term with the biggest power, is this x to the 5. So in this situation, our leading power is equal to 5, which is odd. And the coefficient is equal to 1, which is also odd. So whenever you have an odd power and an odd coefficient, we're going to go down on the left, and then we're going to go up on the right. All right. Again, so all the options that the 4 options that you have, they were on the that one table that we made on one of the videos when we did this section. Okay. How about let's do 17. So what we want to do is graph f of x is equal to x minus 1 cubed, x plus 2 squared. So remember, when we're graphing these, the first thing we always want to do is find the zeros. So let's start with that. So let's set this thing equal to 0, x minus 1 cubed, x plus 2 squared equal to 0. Let's see if we're copying everything correctly. Yep. And so if we solve this, we can easily see, because it's already factored, that x is going to be equal to 1 and x is going to be equal to minus 2. So those are our zeros. So then you remember what we do. We put these onto a number line. Minus 2, 1. And so now we need to pick points in each of these sections. So do minus 10, we can do 0 here, we can do 3. And now we're going to plug it into our equation. Let's rewrite that down again. X minus 1 cubed x plus 2 squared. If we plug in minus 10, and remember, we only care about the sign. If we plug in minus 10, the first number is going to be minus 11 cubed. If we plug it in right here, it's going to be minus 11 cubed, which is a negative number. If we plug it in here, it's going to be a number squared. That's always positive. So this is going to be minus. If we plug in 0, the first term is going to be minus 1 cubed, which is a negative. And the second term, again, since we're squaring it, whatever we plug in here is always going to be positive. So a negative and a positive makes a negative. And if we plug in 3, 2 positives. So that's going to be positive. So now with this, what we can do is we go into our graph and we first put the zeros on. So a 0 at minus 2 and a 0 at 1. And so if we look at our chart up here, to the left of minus 2 is negative, so that means the graph goes down. In between minus 2 and 1 is negative, so the graph goes down, but it comes up and touches 1 again. And to the right is positive, so it just goes up. And so this is what the graph is going to look like. You can also do 18. So let's graph f of x is equal to x cubed plus 3x squared minus x minus 3. So for this one, we still want to start by finding our zeros. It's always the first step when we're graphing these. This one we can factor by using group factoring. Notice from these first two terms, we could take out an x squared and we're left with an x plus a 3. These second terms, we could just take out a minus sign, then we're left with an x plus a 3. Now with these, we could take out these x plus 3s, and we're going to be left with x squared minus 1. And then we could factor x squared minus 1, so this is going to be x plus 3, x plus 1, x minus 1 is equal to 0. And from this, we can see that our zeros are going to be x is equal to minus 3, x is equal to minus 1, x is equal to 1. So now we go to our number line, we put those 3 numbers on it. Okay, pick numbers in each of these sections. So over here, we can do minus 10. Over here, we can do minus 2. Here's 0, and here, say 5. And we're plugging it into our equation f of x. Remember how we factored this to turn it into this. X plus 3, x plus 1, x minus 1. So this is our equation. We factored it down to this piece, and that's what we want to plug our things in to see if it's going to be positive or negative. So we're going to start by plugging in minus 10. We plug minus 10 in here, it's going to be a negative number. If we plug minus 10 in here, it's going to be a negative number. And if we plug it in here, it's also going to be a negative. So 3 negatives make a negative, so we put a minus sign there. The next one, minus 2. If we plug that in the first term, it's going to be positive. Second term is going to be minus. Third term is going to be minus. So that gives us positive. If we plug in 0, the first one will be positive, and then will be positive, and then will be negative. So that's a minus sign. And if you plug in 5, it will be all positives. Okay, so have our chart now. So now we can make our graph. Here is minus 3, here is minus 1, and here is 1. To the left of minus 3, it's minus. In between minus 1 and 1, we have a plus sign, so it goes up, comes down. In between minus 1 and 1 is negative, so it goes down, then comes up. And bigger than 1 is positive, so it goes up. All right, so takes care of that one. Let's do some division ones. So for the following, we'll do a couple of these. We want to find Q of x and R of x given P of x and D of x. So for the first one, and then we could, for the test, if whatever you want to use, we'll use synthetic division or long division. I think synthetic division is easier, so let's just go through that one. Let's do 23. So 23 is giving us that P of x is equal to 6x cubed minus 2x squared plus 4x minus 1. And then d of x is equal to x minus 3. So remember, for synthetic division, put our sign here, and our p of, so we start with our p of x thing. So the biggest exponent we see is an x to the 3, so we need our x to the 3, 2, 1 in our constant column. And so the numbers in front of those variables go there. So the number in front of x to the 3 is a 6, in front of the x to the 2 is a minus 2, in front of the x is a 4, and the constant term is minus 1. And then remember, the number we put out here is we look at the d of x. So it says x minus 3. Since that's a minus sign, we change that and we put a plus 3 over here. So you always do the opposite of the sign. And then the steps are, we bring down the first thing, the 6, and we do 3 times 6 is 18. Then add the minus 2 and the 18, you get 16. That's going to be 30 plus, so 46, or sorry, 48. Add those, we get 52. And then we'll have 156. Add those, you get 155. So for this problem, we have our, and remember, so then these columns down here is going to be one less power from the one above it. So this is going to now be an x to the 2, x to the 1, and then the constant. So what we have here is our q of x is 6x squared plus 16x plus 52, and then the remainder is equal to 155. Okay, 24. This is giving us that p of x is equal to x to the 4th minus 2x cubed plus x plus 5. And d of x is equal to x plus 1. Okay, so let's fill out our table. X to the 4. And the constant. And then our d of x is x plus 1, so we're going to put a minus 1 over here. And then we have 1 minus 2. We don't have an x to the 2, so we put a 0. And then a 1 for that, and then a 5 is our constant. Okay, so pull down the first thing, 1. 1 minus 1 times 1 is minus 1. Add those, we get minus 3. Minus 1 times minus 3 is 3. Add those, we get 3. Minus 1 times 3 is minus 3. Add those, we get minus 2. Minus 1 times minus 2 is positive 2, and add those, we get 7. So for this problem, we have our q of x is going to be, so remember this is x to the 3, 2, 1, and the constant. So we're going to have 1x to the 3 minus 3x squared plus 3x minus 2. And then here our remainder is going to be 7. Okay. Then we could do one more like that. Let's do 25. Or let's do 26. So this one, it's written a little bit differently. It's written as x to the 4th plus 3x squared, or 3x cubed, plus 3x squared, plus 3x, plus 2, divided by x plus 2. So whenever the problem's written this way, this piece right here is going to be p of x, and this piece right here is going to be d of x. So then when we're filling out our table, we'll have 1, 3, 3, 3, 2. Is that correct? 1, 3, 3, 3, 2. Yep. And then since it's x plus 2 for the d of x, we'll have a minus 2 out here. So bring down the 1, then we have, it's going to be minus 2. You add those, you get 1. Put minus 2 here, add those 1, you get another minus 2. Add those, you get 1, another minus 2. Then we get 0. So our q of x, so we start with x to the 4. So this is going to be x to the 3 plus x to the 2 plus x plus 1. And then our remainder is going to be 0. Okay. Let's do one more. How about, let's do 36. So we want to solve x to the 3 plus 4x squared minus 3x minus 18 is equal to 0. So this is basically the same problem as last one. It's a mixture of the previous one. So we need to find the zeros of this, basically solve this equal to 0, but we need to factor this. And if we look at this, we're not going to be able to group factor, and we can't use the quadratic formula because there's an x cubed term here. So if you remember, what we have to do here is do a guess and check. So what we need to do is we need to keep plugging in numbers into this equation until we find something that equals 0. And remember, the ones that we plug in, we're going to start with 0, see if that works. Then we're going to try plus minus 1, then plus minus 2, and so on. And once we find one that works, we're going to do synthetic division with that number. So let's start. Let's try to test these out. What happens when we plug in 0? So we get 0 plus 0 minus 0 minus 18. This doesn't equal 0. So now we have to move on to the next one. If we plug in 1, we're going to get 1 plus 4 minus 3 minus 18, but that doesn't equal 0. So we're going to move on. Try minus 1. We'd get minus 1 plus 4 plus 3 minus 18. Again, that doesn't equal 0. So we got to move on to 2. This would give us 8. 2 times 2 is 4, so plus 16. Minus 6 minus 18. Wait a minute. Pretty sure I just copied the problem down wrong. Oh, sorry. Yeah, this equals 0. We're good. So this equals 0. So 2 is, well, next thing to do is once we find, so a little check mark here, once we find one that does equal 0, what we do is do synthetic division with that number 2. So we're going to take 2 and then do synthetic division with this piece up here. So, x to the 3, x to the 2, x to the 1, and then the constant. So we'll have 1, 4, minus 3, minus 18. And if we do this correctly, we need to get a remainder of 0. So 1, then we have 2, it's going to be 6, then we have 12. That is going to be 9, we have 18, and then we have 0. So remember here, now here's our q of x down here, x squared, x constant. So we see that our q of x is x squared plus 6x plus 9. And then what's our d of x here? Well, if this is a 2, that means our d of x had to be x minus 2 because we always put the opposite of that number. So since remember, if you look at the previous problems, if we had an x minus 2 as a d of x, then we put a positive 2 up here. So now the whole reason of doing this is because we have that one formula that p of x is equal to q of x, d of x, plus r of x. Up here we see that r of x is equal to 0. R of x is always that thing in the box. So then if we plug everything into this formula, remember we were trying to solve this equation up here. X to the 3 plus 4x squared minus 3x minus 18 is equal to 0. But now that's just this piece right here is just p of x. So what we can do is rewrite it by using this equation. So really p of x is the same thing as q of x, which is x squared plus 6x plus 9 times d of x, which is x minus 2, plus r of x, but r of x is 0. So really this piece that we have right here is the same thing as this piece. So what we want to solve is this is equal to 0. But we can keep factoring this. So this left-hand side factors into x plus 3, because 3 times 3 is 9, and 3 plus 3 is 6. And then we still have our x minus 2. And then solving this for 0, we see we get x is equal to minus 3, and x is equal to 2. So these are going to be our two answers. Okay, let's see what else we got from this section. There's only one more type. Oh, yeah, there's only one more type of problem from this section. So that was one of those solving this. Let's do two of those. Let's do 75. Let's start with, let's make one up. So we want to solve x squared plus 3x plus 2 divided by x minus 10 is bigger than 0. So you remember for these problems, we need to find the top zeros and the bottom zeros. That was always the first step. So let's find the zeros on the top zeros. So x squared plus 3x plus 2 is equal to 0. But this factors into x plus 2, x plus 1. That's equal to 0. So we get x is equal to minus 2 and x is equal to minus 1. So there's our top zeros. Now our bottom zeros, just x minus 10 is the bottom, set that equal to 0, so we get x is equal to 10. And then remember, we put these onto a number line. Minus 2, minus 1, 10. Bottom 0, which is 10, always gets an open circle, and the top zeros, it depends on this sign. So since it doesn't have the or equal to part, we put open circles. So now we gotta, test the points, pick points in between each of these sections. So over here, we could choose minus 10. Over here, we could choose maybe minus 1.5. Here, we could choose 0. And here, we're going to choose 11. And then we're going to plug it into this equation, but we want to make sure the top and the bottom are factored. So we already factored the top. That was x plus 1, x plus 2. And the bottom is just x minus 10. So if we plug in minus 10 to the top, plugging it in here, we're going to get a negative. Plug it in here, we're going to get a negative. And minus 10 minus 10, that's going to be a negative. Sorry, not minus 1, just minus. So 3 negatives gives us a negative, and put a minus sign over here. Now we plug in minus 1.5. The top first one's negative, second one's positive, and the bottom one's negative. So 2 negatives and a positive gives us a positive, so we put a plus sign there. Now 0. Both tops are positive, and the bottom is negative, so 2 positives and a negative give us a negative, so we put a minus sign there. And 11, everything's positive. So put a plus sign here. And so what are we trying to solve? Well, we're trying to solve this piece bigger than 0. So since we want to solve it bigger than 0, we're going to take all of our positive sections. And so that's going to be our answer. It's going to be minus 2 to minus 1, and then 10 to infinity. Okay. And the last problem we need to go over together will be one like this, but maybe a little bit. So this one we are going to do 1 minus x, x plus 4. Actually, let's do this. X squared plus 7x plus 12 less than or equal to 0. So remember that always the first thing we do is we find the top zeros and the bottom zeros, but this doesn't have a bottom. Well, the bottom is technically 1. So when we find, let's just first by finding the top zero. So the top is going to be, so we have x squared plus 7x plus 12, equal to 0. We want to find our zeros. So this is x plus, factoring this, we get x plus 3, x plus 4. So x is equal to minus 3, x is equal to minus 4. So there's our top zeros, and our bottom, well, the bottom is always equal to 1. So no matter what, the bottom is never going to be 0, so there's no bottom zeros. So put our zeros onto a number line that we do have, just minus 4, minus 3. And since we have this or equal to sign, we can put closed circles. Oops. All right, so now we plug the points in. Minus 11, split minus 3.5, and 0. And we're plugging it into the, so x plus 3, we're factoring it. So x plus 3, x plus 4, less than or equal to 0. That's what we're trying to solve. So if we plug in minus 11, the first term will be minus, second term will be minus. 2 minuses give us a positive. So it's positive over here. If we plug in minus 3.5, it'll be negative and positive. So that gives us a minus sign. And if we plug in 0, both things are positive. So that's positive. So we're looking for less than or equal to 0. So that means the minus section, which is just this piece right here. So from -4 to -3. Okay. Yeah, I mean, there's no need to do any more. So all of these problems, these will be the test, the chapter 4 problems on the second test tomorrow. So that's really all we need to do for today. So just study these problems, study the problems from the video yesterday. And if any questions, just feel free to email me. Yeah, okay, I think that's all we got to do today. So yeah, I'll see you guys, or, oh no, I'll send an email about the test tomorrow. It'll just be like last time, you have the whole day to do it. Anyway, cool. So good luck tomorrow, and just feel free to email me if you have any questions. All right, thanks.